Let's prepare on dimension and force relations. So let us see the dimensions of various factors. So we have already seen the dimensions of pressure, kinematic viscosity, bulk modulus, everything when we are studying that topic itself. So other than that, in general, how to calculate this, so that we should know, because in questions they'll be giving some unit and they'll be giving the factor and they'll be asking the dimensional unit for that. So here let us see that for a geometric, that is simple length, area and volume, it is L, L square and L cube. Okay, so first remember that for mass we denote it as M, for length we denote it as L, and for time we denote it as T. So here length only L, area L square, that is meter square, and volume it is L cube. And then the kinematic viscosity, kinematic factors. So under that, for velocity it is L t power minus 1. So everything depends on its units only. For velocity we know that it is meter per second, no? So it is L t power minus 1. For time it is t. For acceleration it is L t power minus 2. For discharge it is L cube by t, that is meter cube per second. And then the third sector is dynamic factors. So here for pressure I have given the example. Okay, for pressure we know that the unit is Newton per meter square, or we denote it as Pascal. So what is Newton? Because we don't have dimensional unit directly for Newton, we have only for mass and length and time. So here we have to convert it certainly. So we convert Newton is equal to kilogram meter per second square. So that we take and divided by meter square is there. So when you simplify that, you will be getting kilogram per second square meter. So for kilogram we should substitute m. For second square it is t power minus 2. For m it is L power minus 1. So that is what given here for pressure. Okay, so similarly you can calculate for the rest of the things. For mass m, for force it is m L t power minus 2. For momentum m L t power minus 1. For energy of work m L square t power minus 2. For power m L square t power minus 3. The next thing we are going to see in this lecture is the force relation. So this is very important. Several times they have asked this. Okay, so we are going to study just 5 different numbers and the relation between them. So that is what is important here. So the first one is Reynolds number. We have already seen this. So it is the ratio of inertia force by viscous force, and we denote it as RE. Okay, so for the following 5 factors, the numerator will be inertia force only. So you can remember that easily. Study the denominator alone and keep it in your mind. So here inertia force by viscous force, which is equal to rho Vd by mu. So that is the formula for Reynolds number. The second factor is Froude number. So this also we have seen, it is root of inertia force by gravity force. So which is equal to V by root Gd. The third one is Euler number, which is equal to root of inertia force by pressure force, which is equal to V by root of del P by P. The fourth term is Mach number, which is denoted as M, which is equal to root of inertia force by elastic force, which is equal to V by root of K by rho. So V is, here the terms I didn't say, no, so the V is nothing but the velocity, D is the diameter of the pipe, rho is the density of the fluid, mu is kinematic viscosity, and then G acceleration due to gravity, del P and P is the pressure only, and here K is nothing but the bulk modulus. And then Cauchy's number, it's nothing but the square of Mach number. So it is inertia force by elastic force alone. And then Weber number, so Weber number W is equal to inertia force by surface tension force, so which is denoted as rho V square L by sigma. So sigma is your surface tension and L is your length of the pipe, or in sometimes we'll be taking the diameter of the pipe also. So this is all about your relation between the various force factors. Thank you and keep watching.